Hello teachers, welcome back. Let's talk about section 13-5, which covers volume, mass, and temperature. Students will be able to understand and explain volumes of prisms, cylinders, pyramids, cones, and spheres. We're going to be converting metric measures of volume, converting English measures of volume, ratios of volume of similar figures, and measures of mass and capacity. So these are our outcomes. We'll cover that in this section. Got a question for you right off the bat. What is the volume of each figure, and what is the surface area of each figure? So take those in and let's discuss it. So look at the first figure here. These are simply units of volume. So if you were to count, we have, notice 1, 2, 3, and then 4, 5, 6, 7. Now likely there are 2 back here, so that would be 8, 9. Do you see that? So again, 1, 2, 3, 4, 5, 6, 7, 8, 9. And we've got 9 cubic units. Now I didn't check the next one. Let's check the next one. All right, so we've got 1, 2, 3, 4, 5, 6, 7 hidden back there, 8, 9. So both of these volumes are 9 cubic units. Now what about the surface area? Remember, we talked about surface area in the last section, and you're talking about faces that you're dealing with. And so these surface areas are square. And I think it would be easiest to calculate this by keeping up. It's going to be a little bit more difficult to keep up with everything, but let's count what we don't see first. You want to, so the back side of all of these, let's count that. So that would be 1, 2, and then in the far corner 3, 4, 5. So I would see that there's 5 in the back that we don't see. Let's count again, 1, 2, and then at the bottom corner 3, 4, 5. Now what about the back side over here? That's on the bottom row, 1, 2, 3, 4, 5, and then 6 back there. Now what about underneath? So I see there's 1, 2, 3, 4, 5, 6 underneath. Now let's count the front facing side. So that's 1, 2, 3, 4, 5. Or let's just, that's more confusing to me. So let's just count the faces that we can see. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I think that's 17. I'm going to count it again from the top. So there's 3 right here. 1, 2, 3, and then 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Yes. And if I add these together, I've got 6 plus 6 is 12, plus 5 is 17, plus 17 gives me 34. And we don't know what these units are, but we know it's units squared. Now, I fear when I look at the answer like I've left something out, because that's kind of challenging to keep up with. Oh, there it is, 34 square units. Yay! Okay, now here's what I want you to do. I want you to pause it and see if you can calculate the surface area on your own. And I say calculate, but really you're counting, right? So see what you can do with that. Okay, I'm going to try it too. So I'm going to do the back side again. So I've got 1, 2, 3, 4, 5 on the back side. Okay, and then the side facing back this way. Okay, so that's going to be 1, 2, 3, and then 4, 5, 6. Okay, now what about underneath the bottom here? So that's 1, 2, 3, and then the back row 4, 5, 6. And now I'm going to count the faces that I can see, and I'm just going to check them as I count them. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I'm seeing 18 there. And if I add these up, I have 6 plus 6 is 12, plus 5 is 17, plus 18, that's 35 units squared. And again, I fear looking at the answer just a little bit. It's 36 units squared, so I left somebody out, clearly. So I'm going to take their word for it, and you probably see the one that, oh, I know what I left out. I know exactly what I left out. Look. because I didn't account for it in my situation. That back side of that blue one, I didn't count it. So it is 36 units squared. Not that I doubted them, I doubted my counting, but I'm glad I figured out which one it was. And that brings us to our first formula. We'd rather use formulas than count all those faces, right? So the volume of a right rectangular prism, and you know volume, you've worked with it before, maybe not in this class, but I promise you've worked with it before. So volume is length times width times height when you're talking about a rectangular prism. So you need a length measurement, a width measurement. In this case, that's front to back, where length is across the bottom here, and then the height. Now, how about converting metric measures of volume? So what you have here pictured is a decimeter cubed, because volume is units cubed. We talked about that briefly when we were counting the number of blocks we have. Those were cubes. All right, so if you have a decimeter cubed, that's the same thing as 1,000 centimeters cubed. And so a decimeter is probably about the width of your hand. And so if you picture that this across the bottom, about the width of the palm of your hand, and square here, but in a cube, so square face and then all the way back. If you split that up into centimeters, there would be 1,000 of them. All right, so what about if you're talking about in meters? Well, 1 meter converted to centimeters, notice that is 1,000,000 centimeters cubed. So 1 meter cubed is 1,000,000 centimeters cubed. 1 decimeter cubed, okay, is 1/1000th of a meter cubed. Wow, right? Now, when we're doing conversions, if you like, you can use dimensional analysis. Remember our fractions when we're converting, and you could use the fact that 1 meter cubed is 1,000,000 centimeters cubed, or 1 decimeter cubed is 1/1000th of a meter cubed, and the other relationships. Or you can go back and remember King Henry died by drinking chocolate milk, where you write kilo, hecto, deca, and then the base, whatever the base is, okay, deci, centi, milli. Now, if you're just talking about linear measurement, in other words, just plain old kilometers, hectometers, decameters, meters, decimeters, centimeters, millimeters, every time you move on the list, if you move to the right, you move your decimal to the right. If you move to the left, you move your decimal to the left. And what you're memorizing, just to refresh your memory, or maybe this is the first time you've seen this, king represents kilo, H represents hecto, D represents deca, bi means base, D is deci, C is centi, by now you've got it, M is milli. And I don't have to write it like this, I just write King Henry died by drinking chocolate milk. You may hear me say King Henry died Monday drinking chocolate milk, because that's the way that I learned it, where Monday represented meters. Okay, now in the area section, we were talking about meters squared or kilometers squared or millimeters squared. Every time we moved along the line, it was 2 units. So you would count 2, 4, 6, 8, 10 if you had to go that far. Well, y'all, when you're talking about volume, every time you move, it's 3 units. Okay? Every time you move, it's 3 units. So rather, it's up to you how you want to do it. I firmly believe in dimensional analysis, but this King Henry deal is so easy to use, and I think it's something your students will remember forever. So King Henry died, remember, by drinking chocolate milk. It takes no time to write it down. If I'm talking meters cubed, I'm right here in the middle. That's my base, meters cubed. But since I'm cubed, we're talking volume, then every time I move, it's really a jump of 3. So we're moving to centimeters cubed, that's 3, 6. Okay, so that's 6 moves because we moved to the right. That's 6 moves to the right. So the decimal sitting right here right now, 6 to the right, would give me 5 million centimeters cubed. So that's how it works when I check my answer. Well, we'll check our answers in just a minute. Okay, now let's try it again. Okay, I'm going to erase my scratch work down here below and do another problem. All right, so I'm starting with millimeters cubed this time. Again, notice the cube, that matters. That means we need to move 3 each time we jump to a new unit. So we're starting at millimeters, and so that's going to be, and just going to centimeters, so that's just a jump of 3 to the left this time. The decimal is sitting right here, so the 3 to the left would be 12.3. You can write those zeros in the back if you like. 12.300 centimeters. Really, that's read 12 in 300 thousandths, which is the same as 12 in 3/10. Okay, now let's check our results. And there it is. And remember, the zeros after not required. So again, if you are teaching this to young students, I think they will really like the King Henry deal. But of course, you handle it how you like. And again, I don't disagree with dimensional analysis. It's a great way to handle it. But it's more memorization than what we're doing right now. All right, so I got something new for you here. 1 liter. So let's talk about another measurement of volume. And often this is used for liquid volume. So turns out 1 liter is the same thing as 1 decimeter cubed or 1,000 centimeters cubed. All right, so suddenly it's like we're going from linear measure, which we weren't because it was cubed, but we took a linear measurement, turned it into volume, and now we're creating a new unit, still a metric unit, called a liter. Okay, and this gives you an example. Remember, a decimeter is about the width of your palm of your hand, so picture a 3-dimensional cube, which every dimension is about the width of your hand. That would give you a liter. If it was filled up with water, you would have a liter of water. And what this liter character does, it's another base unit. It opens us up to a whole new situation of King Henry, of the metric system. So a kiloliter is 1,000 liters, a hectoliter is 100 liters, and a deciliter is 10 liters. Those are the same base unit measurements. Deciliter is 1/10 of a liter, a centiliter is 1/100th of a liter, and a milliliter is 1,000th of a liter. Just like if that was a meter there lined up, we have the same thing. So the King Henry that I love so much applies to liters as well. So let's do a few conversions. All right, and again, how fast is it? King Henry died by drinking chocolate milk. This time, though, our base unit is liters. And why I make the K capital all the time? Probably because my first name starts with a K, and I'm so used to doing that. But you certainly don't have to. Now, we're going from 27 liters, that's our base unit, moving to milliliters. Now, we are still talking volume, but we're not talking about liters cubed, because you don't do that with your liter measurement of volume. So every time we jump around, that's just one jump. So 27 liters, I count 3 to the right, so I move my decimal 3 to the right to get from liters to milliliters. So that's 27000, or 27,000 milliliters. Okay, how about you pause it and finish these out? Okay, so we have 362 milliliters. I'm starting at the far right. I'm moving to liters. That's 1, 2, 3 jumps to the left. So that's going to give me 0.362, or 362 thousandths liters. Okay, this one's starting with milliliters again, but I'm going to centimeters cubed. Now that's a little bit different, right? So we need to go back and look closely when we talked about the conversions from volume to our new liters. Notice we have 1,000 centimeters cubed is equal to 1 liter. Does that help us? Is that what we need to know? We're dealing with milliliters. Notice in green is really the important detail we need to know. I think it would help you the most to remember that the conversion here is that 1 liter is 1 decimeter cubed and 1 milliliter is 1 centimeter cubed. So if we go back to our problem, we have 3 milliliters. You know what that is? That's the same as 3 centimeters cubed. Okay, so again, 1 milliliter is equivalent to 1 centimeter cubed. Okay, and then 3 meters cubed we want to convert to liters. Now we also remember that 1 deciliter is equal to 1 liter. So what if we change this to deciliters, and then that would be easier to convert. So we have 3 meters cubed. That's here, right? And we're converting to decimeters cubed. But remember, that's 3 jumps when you're dealing with cubed values. And so that will give us 3,000 liters because we're going 3 for each jump. So we went to the right, and that's 3. And then again, that's the same as 3 decimeters cubed, which is equivalent to 3,000 liters. These are equivalent. Now let's check our answers real quick. Okay, so the first one we had 27,000. That does match what we have. The second one we had 0.362. That does match what we have. The third one we have 3 centimeters cubed. That also matches what we have. And the fourth one, that's our 3,000 liters that we converted to decimeters cubed first, and then converted that to liters. Now here's a list of your English measures in terms of volume. So a cubic inch, and you know how big an inch is, so turn that into a cube. That would be a cubic inch. A cubic foot, a cubic yard. Those are often measures that we use to measure volume. Also, we know 1 gallon is equivalent to 231 inches cubed, and 1 quart is 1/4 of a gallon. I tend to think more the other way, that 4 quarts equals 1 gallon. That is saying exactly the same thing, right? And also, what's not included here that you might need to know, that 1 pint is equal to 2 cups, and I'm writing this backwards. 1 quart is equal to 2 pints. And then we have, again, 4 quarts is 1 gallon. I didn't notice these in the homework, so I'm not stressing over you getting those values, but those are common values that we see when we're talking about volume equivalents. Now, let's talk about converting from, say, inches cubed to feet cubed to yards cubed. And let's just do some examples where we talk about it. So we want to convert 45 yards cubed to feet cubed, okay? I'm going to do my classic dimensional analysis here. We need to do it anyway. So we've got yards cubed. Remember, dimensional analysis, we multiply by a fraction that's equivalent to 1. Whatever you're trying to get rid of here, and that really is considered in a numerator, you put in the denominator because we want it to cancel out. And if there is a conversion between the value you're trying to eliminate and the value you're trying to change it to, then you put that value in the numerator. Okay, now the ultimate goal is to get these yards cubed to cancel out, but I'm not going to do it yet. Now, what is the conversion? Don't worry about the cube yet. What's the conversion between feet and yards? And I know you know this. There are 3 feet and 1 yard, right? Now, when you have this cube out here, I need you to realize that there's some parentheses that go right here. Okay, so this is the same thing as saying 45 yards cubed times this fraction. Now 3 cubed and feet cubed gives me 27 feet cubed. And then 1 cubed and yards cubed gives me 1 yard cubed. You see what I did there? So you don't necessarily have to have it memorized that to convert feet to yards or yards to feet, that there are 27 feet cubed and 1 yard cubed. You can remember your linear measurement and cube that value, and that'll be what you need. So when I cancel my yards cubed now, then I multiply 45 times 27. You also remember the trick, right? That you're going from big to small. So big, you hold your arms way out because you're being big, and then you put them in front of you and cross over. To small, that means we multiply. And notice that's what the dimensional analysis did for us here as well. So 45 times 27 gives us the value 1,215. And this is feet cubed. Uh-oh, again, I know that probably looked crazy on the screen, but I apologize. I got too close to the edge. There we go. So 1,215 feet cubed. Now see if you can do the next one on your own. How'd that next one go? Okay, so let's start with what we know. We know there's 4,320 inches cubed. We want to convert that to yards cubed. Now, I know I need to put inches cubed in the denominator. And is there a conversion between inches and yards? Yeah, there is, right? You know, there's 36 inches in a yard. So we can jump straight there if you know that. So I can go to yards cubed. And remember, there are 36 inches in 1 yard. But don't forget, when you cube, you have to cube the whole thing. So really, this is equal to 4,320 inches cubed times, now 1 cubed is still 1, so that's 1 yard cubed, and 36 cubed, that's 36 times 36 times 36, and that's 46,656. Inches cubed. Those inches cubed are going to cancel out, and I'm going to end up dividing. So 4,320 divided by 46,656. So I get a pretty small number. There were no instructions of where to round this. Notice we were like 3 significant digits when we started, 1, 2, 3, 4. So it would be reasonable to take this out 3 significant digits. So 1, 2, 3, 4. So we could round right here, and that would make that a 6. So 926, what, 10 thousandths? 10 hundredths? Yes. Okay. So 926 10 thousandths yards cubed. Now let's check our results. So the first problem, we did get 1,215 feet cubed. And the second one, there we go, over here. Notice they rounded it a little further than we did. Maybe just to make things more clear. But we actually rounded here, thinking about significant digits, and they just rounded that up to 0.1 yards cubed. Now, so it looks a little different when they did it, but it is the same result. Next problem, we're taking 10 gallons down to feet cubed, or over to feet cubed, I should say. There's nothing down about it. Now, do you remember the conversion between gallons and feet cubed? I'm afraid I don't at all. It's not something that I think about very much or have had to use very much. I'm trying to find it right now. I'm even struggling to find it. There it is in our work. But 1 gallon is 231 inches cubed. So I am reading this. Okay, so 1 gallon is 231 inches cubed. Don't fret, I'm not going to make you memorize that. Now I'm struggling to figure out where we were. Okay, again, 1 gallon. I'm going to write it down over here. 1 gallon is equal to 231 inches cubed. Okay, so if we have 10 gallons, we'll start there. So 10 gallons. I'm going to use my fraction, my unity fraction. If I'm trying to get rid of gallons, it needs to go on the bottom, what it's equivalent to. Or I'm trying to change it to inches cubed for now. It's going to go on the top. Because that's all I've got, y'all. I can't change it to feet cubed. I don't know what that conversion is yet. So I know that 1 gallon is 231 inches cubed. So the gallons cancel, right? But I'm still trying to change that to feet cubed. So now my inches cubed is on top. I'm going to get rid of it, so it goes in the bottom. And I'm trying to change it to feet cubed. Now remember our conversion, there are 12 inches and 1 foot, but when you have that exponent there, it has to apply to both of them. I'm going to get rid of my conversion over here for the space. I knew I would need that space and shouldn't have written it there. And here we go. Okay, so 12 to the third. What is 12 to the third, y'all? I know 12 squared is 144, but 12 to the third is 1,728. And now that's inches cubed. Okay, so your inches cubed cancels here. All right, and so I'm going to take 231 and divide by 1,728, and that's going to leave me with the feet cubed that's still there on top. So 231 divided by 1,728 gives me 0.13368, and that's feet cubed. Notice we were only two significant digits here, so I would say 0.13 feet cubed is about all we really need there. Okay, they took it a little further, and they've got 1.337 feet cubed. Did I divide wrong? No, folks, I didn't divide wrong at all. Do you see what I did? I'm having a day. I forgot to multiply by the 10. Oh my gosh, that's terribly important. So 10 times 231 divided by 1,728 will move that decimal over and be exactly what they have as their answer, and they took it out to there. So 1.337 feet cubed is the answer they have. I apologize. You're going to have to watch me today. All right, let's try this again. So 3 feet cubed. Let me make sure I really pay attention to what we're starting with. 3 feet cubed. I'm trying to change that to yards cubed. So dimensional analysis says I can multiply by a fraction, and I'm going to put feet cubed in the denominator. And if I have a conversion from feet to yards, I'm going to use it. And I do. What's the conversion? We know there are 3 feet and 1 yard. But because we're cubing this, I need to put parentheses around the units and the amount because I'm going to have to simplify this first. So I'm still starting with 3 feet cubed. I think that's what I did wrong before. I had been rewriting that original line and I didn't over here, and that just made a big old mess, didn't it? So 1 cubed and yards cubed is 1 yard cubed. 3 cubed is 27 feet cubed. Now what happens is my feet cubed cancel out, and I say 3 times 1, that's 3, and the denominator 1 times 27 is 27, and notice what I'm left with is yards cubed. That would reduce to 1/9 of a yard cubed, or you could type that in your calculator. Okay? So let's check out our answers. We already knew the 1.337 because I went and checked it and went, oh no, I messed up because I forgot to multiply it by the all-important 10 that we started with. And this one, I paid attention to what I was doing a little bit better, and there's the 1/9 that we talked about, and it's perfectly fine to leave it like that. That's exact, whereas when you round this to 0.1, you know 1 divided by 9 is just a 1 repeating forever. Okay, it's a repeating decimal, which is 0.1 if you round it to the 10th place. Okay, so now we want to start talking about the volumes of a cube, which we've mentioned already, and a prism, and cylinders, and even getting to cones and pyramids. We have something called the Cavaliere's principle. 2 solids, each with a base in the same plane, have equal volume if every plane parallel to the bases intersects the solids in cross sections of equal area. Now what's that really trying to say? I think this image here does a great job of explaining this. So if you just slice this into cross sections, notice these are all vertical and line up. So this is like a right prism, right? Or a rectangular solid is what you see, right? Well, if this was leaning to one direction or another, those cross sections are still going to be in equivalent area to if it were straight up and down like this, and that means they have the same volume. You can imagine having like a deck of cards, right? You know the volume of a deck of cards, and you just push a few cards or put your finger in there and it pushes some of them over. You agree it's still the same volume, right? They're just not lined up as a right prism anymore. And so this is a very interesting principle, and it makes it easier to calculate volume of some unusually shaped figures. Now we want to find the volume of each of these figures. Let's do that real quick and call this video done. Not the section done, just the video done. We have more to discuss. So find the volume of each figure. We have a cube. Remember, the important thing about a cube is every measurement is the same. So if the height is 6 centimeters, that also means the distance from front to back is 6 centimeters, and across here is 6 centimeters. So we have 6 centimeters times another 6 centimeters times another 6 centimeters, right? That's going to be 6 times 6, which is 36, times another 6, I think is 216, but I don't want to jump in there too quickly. It is. So we have 216 centimeters cubed, right? Because centimeters times centimeters times centimeters is centimeters cubed. Remember, that was the same thing as a milliliter, a centimeter cubed. So this would also be 260 milliliters if you wanted to fill it up with liquid. All right, what about a right rectangular prism? So it's the volume of a rectangular prism is length times width times height, okay, in no particular order. So this volume, the length, we could say is 10 centimeters if you want to. The width is 3 centimeters. The height is 15 centimeters. And remember, it matters not what order you multiply these in because of the commutative property of multiplication. So we know 10 times 3 is 30 times 15 gives us a value of, because I don't want to do it in my head, 450 centimeters cubed. All right. Now, when you're dealing with the volume of a figure that you know the base, it's really going to be a formula, y'all, as base times the height. That's really what we're using here, is the base times the height. As long as it stays consistent all the way up. So those cross sections, like the Cavalieri's principle, as long as it's the same exact figure, when you slice it all the way up, it's going to be base times height. Is exactly what we did here too. The area of that base is 6 times 6 is 36 times the height was 6. Or the area of this base was 3 times 10 is 30 times the height is 15. We're going to do the same thing here. Now, what's the base? Well, that's a circle, right? And that was supposed to be green. Let's shade it in right there. See that circle is a base? So what's the formula for a circle? Well, it's area, right? So I should say the area of the base times the height. So the area of the base here is pi r squared. What's my r? 5 centimeters. So this is going to be pi times 5 squared. It's really 5 centimeters squared. Times 10 centimeters. Now, let me go back and put the units in there because I want you to be very clear about the units for volume. So this is 5 centimeters and the squares on the outside. This is pi r squared, again the area of this circle, times the height, which is 10 centimeters. So this is going to be pi. 5 squared is 25. Centimeters squared is centimeter squared times 10 centimeters. So this is going to be pi. Now we can say 25 times 10 is 250. Centimeters squared times centimeters is centimeters to the 3rd power. In other words, volume. So the volume is 250 pi centimeters cubed. Now what do you do if you need it won't be an exact answer, y'all. If it's got pi in it, you got to round. But if you needed to know an approximation, you say 250 times 3.14 centimeters cubed. But it's easier to leave the pi value in there because that's an exact value. Now, I've gone about 4 minutes over what I always promise you I'll be finished. So we're going to have to come back for part 2. I have quite a bit to discuss. There may even be a part 3 that goes with this video. But I'm going to try to hurry up when we come back. Hope you have a great day.